Okay, morning everyone. Welcome to this session number 439. And today I have this problem. It's a hard problem. It's part of the contest. The last contest is this the longest special path. Um, and is this okay? And the problem is the longest special path. You are given an undirect tree route at a node 0 with n nodes numbered from 0 to n-1, represented by a 2D array h of the length n-1, where h in the index I is equal the origin, the node ancestor, and the b represent the direction where have this h. In this case, is indirect, but for the representation of the problem is basically a direct graph, because it's in this direction only. However, you are also given an integer array nums, where nums in the index I represent the value of the node I. And a special path is defined as a downward path from an ancestor node to a descent node, such that all the values of the node in the path are unique. Note that a path may start and end on the same node. Okay, this is important. And the other is that return an array result of the size n, return an array result of the size 2, where result in the index 0 is the length of the longest special path, and result in the index 1 is the minimum number of nodes in all possible longest special path. The minimum number of nodes in all possible. Okay, got it. And now we have this problem, this example. Yeah? Now here I try to solve in the contest, but I can't. Okay, color. This is the result, and this is the image. Where the nodes are colored by the corresponding values in nums. For example, the red with red means the 2. Blue is 1. In green, I think that is okay. Now, oh, okay. I think that it's enough. Now, okay. I need to update the color. Okay, the idea that I have in this moment, okay, this, well, in this case is red, because is the node 0. In the node 0 is this, in 0, 1, 2, 3, 4, and 5. And in this case, we are saying we have one node 0, go to node 1, yeah? And in this case, the value is 2, and the color of the first is red, and the other is blue, yeah, because the one is another color. It's only one representation. But well, this is the meaning of these values: origin, destination, and in the value. Yeah. Now we need to try to figure out what is the longest path where all the colors are different and obviously contiguous, like this, for example, red, okay, blue, okay, we have 2. Yeah. Now if I go to this, I have two reds, means that I need to remove this and only keep this. Yeah, in this case is another two. And if I have this path and I still moving, in this case we have another blue. Okay, here I have two again. Okay, now another path is, for example, here, and if I move to this, yeah, we have two blues, means that I need to remove this and remove this and only still in one. I have one. And the other path is this here. Okay, are different. Now here are different because it's the only green here. And in this case, um, this is the longest path. Yeah, and the sum of the this is 6, and the number of h is 2. Yeah, and yeah, and essentially is this. But the problem said return an array of the says an array with two slots. The first slot is the length of the longest special path, yeah, and the other is the minimum of nodes in means that in we um, we will find many special paths like this, this, and this, and the minimum of a number of nodes in all possible. In this case, for example, the minimum is 2. The minimum is 2. Why? I have a few doubts here because, for example, why a single node is not considered here, because a special path is defined as a downward path from the ancestor node to a descendant node. Okay, but here note that a path may start and end in the same node. And for example, here we have the the node 0 go to the node 0 go have a connection with node 1. Yeah, the value is 8. And here, for example, is 0 because both have the same color. Yeah, means that still in 0, and 1 because it's the only line. This is my toe. But what, however, moving with this code, I had the idea to track the longest path, uh, having all the time the record of how many or which colors I have until this point in the path. For example, in this case, it's empty because it's the first. Means that I can add. Okay, when I move to the next, yeah. In this point, I'm sure that I have the red, and this is the let me clean. Okay, and this is the colors that currently I have until this point. Yeah, the idea is that don't allow the duplication. For example, in this case, the color red. In this list, because it's a list, contains the color blue, no. Okay, means that I can move to the next having this color. For example, in this case is red, and the most new or newest is the blue. Okay, Now is asked the red is contained in this list, and we need to check. No, we need to check only in general. Is contained here? Yeah. Now the next is start removing the first all the oldest nodes. For example, in this case, the red, and ask again, the red is contained in this list? No. Okay, now I can continue only with two colors. In this case is blue, that is the, in this moment is the old node, and the newest color is this. Yeah. And here as again, the blue is contained in this list. Yeah, we need to start for the oldest color, and as again, blue is contained in this list of colors. No. Okay, means that I can move to the next and have, for example, red, and the newest is the blue. Let me explain with an extra color like this, for example. It doesn't matter right now the values. It's only for identify the longest magic path. Now, in this case, for example, now here we know that the previous or previously in the path, I have the color red. Blue is contained in this? No. Okay, now here is red and blue. Okay, and we need to ask, red is contained here? Yeah, we need to remove the oldest elements. And for every time that I remove, I need to ask, the red is contained. In this case, is not. Means that I can move to the next. In this case, blue, and the newest is the red. Yeah. And now here is asked, the blue is contained in this list. Yeah. Okay, we need to start removing the oldest elements. And again, blue is contained here. No. Okay, means that I can move to the next, passing these values. In this case, the oldest value is the red, the newest is the blue, and now we need to ask, green is contained here? No, means that I can add. I don't need to remove anything. Yeah. And in this case, I have three elements. Okay. And in this moment is the longest path. Yeah, and basically in every time I can remove the elements. Why I am removing the oldest elements? Because for example here, um here, blue is in this list. No. Okay, I can pass the list here, and now in this point is the red is contained here. Yeah, I can only remove, and even in this moment, it's only enough this operation one time. Yeah, because yeah, yeah, it's only performing one time. If you remove one, for example, the red in this list, it's sure that only appear one time. Yeah, but well, however, now here we need to ask, the red is contained in this list? Yeah. Why I need to start for this and not for this? Yeah, because in this case it's a while, I think, taking the oldest elements and not the newest. But why? Okay, the reason is because, for example, this is the current path, and if I am here, don't make sense continue or start here. Yeah, because for example, I have another element here. Don't make sense start here in the middle, or in this side. I need to start for this because we need to discover in which point this red is have a different color. No, we need to discover in which point appear the red, and in this moment could this path. Yeah, and instead have this, only have the path that don't contain the red. In this case, it's only this. Yeah. Okay. Now, having this in mind, another point is that we need to For example, if I am have the red here, blue is contained here. No, okay. Now is red, blue, and then we need to ask two. Red is contained here. Yeah. Okay, this is remove it. But when you remove it, I need to know what is the value of this. In this case, for example, this is related with this, and the value is sorry, not this, is this. Yeah, we need to know this value. Why? Because, for example, the sum of 2 plus 3 it's equal 5. Yeah, and in this case, if I remove this, means that I need 5. Sorry, it's a terrible color here. 5 less 2. This is the, yeah. 3 plus 2 it's equal 5. Now the total here is 5. If I remove the red, I need to remove this. 5 less 2 it's equal 3. That represent the current path. Yeah, that is only this 3. Yeah, and obviously the number of age is 1. Now for this, I am thinking that maybe instead of only save the colors, for example here the color red and blue, uh, instead have this oh, maybe have a map. Yeah, maybe have map like this, and have the color here. In this case, the colors is the numbers, the index. Sorry, no, is the number. This case, no, it's the color and the okay. I need to relate this with the color. Oh, okay. I think that I can have uh, the queue because we need to insert in the front, but remove the oldest. It's at the queue, and the queue is an integer, an array. Uh-huh. Okay, I need to check if this is possible because my idea is having the queue that every item in the queue basically is this, yeah, with the color obviously at the beginning, and use only the color, or well, in this case the value, uh, as a key for ask the queue contains, or the queue contains the color red. If it's contained, well, it's removed. But I need to figure out if it's possible. I think that is possible, but I'm not sure. The queue operation Java mm, contains uh, mm, mhm. Okay, and here compare. Yeah, it's overrated the queue. The compare. Okay, or another option. Okay, I can use mm, oh no, in this case I can use an stack for the behavior that the I can use an stack, but how can I know that the color red exists in the stack? Because the color red is two. The two is in the stack. Is for example, yeah. But how know that this red is related with this? Mm, okay, I think that is with this. Uh, but it's less expensive. Um, things time complexity. The search operation takes yeah. Searching. Mm, you but the operation of contains. What is it? Mm, in directly contains meta complexity linear. Yeah, expensive, but it's the only way to know because in this moment I perform this operation and continue with the next. If in another moment I need to come back to this, I know that the current array contains only a single element. Hmm. Okay. Okay. The first is create the queue. at this element and ask contain it. If it's not contained, I can add and continue with the next. And return array, the length of the longest special path. In this case, the longest is 3. No, is is 2 because is this the length of the longest special path. And the length is represented by the last value here. In this case, these values. Okay, in this case, 3 and 6 can be because have the same color here. Uh-huh. Is my previous try solving this problem, but it's wrong. Okay, in every time that I add a new element, is get the total and have the max in the length and is the minimum number of nodes in all possible. In this case, is only have the what is the minimum. The number of nodes. The first is integer longest equal 0. Integer mean nodes equal integer okay, I need the have the or know the maximum value here, but in this case, for example, I can put integer dot max value. Okay. Okay, one moment, please. Okay, I'll be back. Now, okay, I have the minimum nodes, max. Okay, the next is the DQ. it's the queue of mm, integer. I'm not sure if I can do this. Mm, Q is equal new and get the list, and inside them the comparator. But I think that is possible, but well. Um, Q, what is the next? I think that all. Okay, now the first is create the map. For example, 0 go to 1, the 1 have 2, 3, and 4 as a child or children, say children, right? And in this case, for this I need a map, hash map. Integer, and here is a list of the nodes. I can understand how this kind of problems like this, these people can resolve in this time. It's ridiculous. In 3 minutes, I can understand. Well, in this case, this is more reasonable, but the other times, this time is a crazy thing. 3 minutes. But well, now this is map. It's equal new hash map. And now the next, well, it's iterate over this map, over the elements for the find. The 0 have one child, that is the 1. The 1 contains the 2, 3, and 4, and whatever. Now here it's H, H, and H. Now here, it's if map dot contains key, the contains key is H in the position 0. Because the position 0 is the origin, and I am creating this with the if it's not contained, map put it easily create the list, new array list, and in this point I am sure that exists map.get h in the position 0, that is 0. Do you remember it's a list path, and h in the position 1, that is this with this. But here I think that I can say directly because the 2 I lose this value. Okay, I think that I can save the step this. I'm sure that here is in with objects. They get like this and only put the H. Or new int value of h in the position 1, that is the destination, and h in the position in the position 2 that represent the length, this. Uh-huh. If I follow this, initially 0, have a child, this case with 1, and the length is 2. Uh-huh. And continue with all of them. Okay, here the mean of nodes, this case is 0, and here I can replace by the max. Math.max is only for figure out what is the value of n, because here said that is n is 1. Okay, here is h in the position 0 and h in the position 1. What is the max? And this is the value. Okay, now that I have the mapping the graph. Now it's start the or perform the operation of transversal the tree. Integer I is equal 0, meanwhile I minor that even here, what integer n equal 0, and it's equal math, and here is in nodes, it's equal n, and in this case, meanwhile I it's minor that n, I plus plus, because here we have the statement that node 0 rotate and node 0 always starting 0, and n in n less 1 in this case is 5. Do you see? Is the greater element in the list. In this case, well, I can figure out with this. Okay, now it's start with 0 0 1 2 3 and 4 until this point. And I start here. Mm. But if I start in 0, for example, this, I apply a DFS, forget the values of 0, that it's only 1. Okay, now the 1 contains these elements, go to the first. Now this again, all the elements is this, come back, and this is finished, come back, go to the next. In this case, have the same color, it's ignored. This is complete. Now go to the next, the one has been checked before. Okay, in this case, I think that it's only enough applying the DFS over with the 0. It's not necessary this DFS 0 in here private what I should return. I think anything, because I can have these values as a global and only replace. Hmm. void dps um integer node begin, in this case is 0. Yeah, now if in the DPS should we have the tracking of the colors like this list. This case is the queue. mm, Colors, only for identify the colors. Now mm, I need to ask if the current node exists. For example, I'm here, go to the next. This exists in the list. If exists, I need validate that current node doesn't exist. Colors. Colors. If exists, you remove it. Other case, continue. And okay, it's colors contains here. I need to override the compare. If it's contained, I need a while and ask meanwhile colors is empty but negative, and colors is pop front. I'm not sure if it's pop front to Java. At first, the original is remove last. I think that is remove last. I need to take this, but I think that if this it's equal to node, in this case, for example, if I have a red, blue, and node is red, I need to start with the first red and remove it. It's equal red, yeah, and here don't do anything because the operation is applying here, or I can pick last, and here is colors that remove last, yeah, and now it's colors dot add, no, uh, At last, I think that no, it's at least. At first, node is not node, is colors, the values here. Um, Tiger color array colors. Oh, uh-huh. It's only for have the reference. And now the node, for example, the node 0, I need the value node. Okay. No colors. No, but color. No, this is a single element, but I need all the values, all the. Uh, ah, a little this problem. But well, I think that it's enough for this transmission. Thanks for following this streaming, and I hope see you in the next. Bye bye.